Greetings and welcome to the Data Armory. Today we are going to look at the easiest way to learn data science. You know very well that it's very easy to get frustrated when you spend a lot of time and money trying to learn programming or data science, but things in the end do not seem to make sense. While on the other hand, everybody else appears to be on a smooth sail. They are building projects and earning all the dollars before you. That means that there is something that you need to change, and that is how you are learning. So let me show you one of the best ways, if not the easiest way, to learn programming. And therefore, we are going to look at and define what active learning is. And as an example of active learning, we are going to look at peer instruction and at least understand what peer instruction is. Then at the end of this study, at least you should know and be able to implement active learning strategies. At the end of this, you should be able to know and at least implement active learning strategies. So what is active learning? What is active learning? This is Vanderbilt.edu. There is an article on active learning by Cynthia J. Brem, PhD, CFT, Assistant Director. Now, in discussing what active learning is, she says that it's noted here that in their seminal work, Active Learning, Creating Excitement in the Classroom, compiled in 1991 for the Association for the Study of Higher Education and Eric Clearinghouse of Higher Education, Bonwell and Eison defined strategies that promote active learning as instructional activities. Now, what did they define these strategies to be? These strategies that promote active learning to be? They define them to be as instructional activities involving students in doing things and thinking about what they are doing. So we are talking about the easiest way to learn programming, and just that by the fact that we have already mentioned what active learning is, which is about instructional activities involving students, that already should give you the first point that the easiest way to learn programming is by being involved in doing things and thinking about what you are doing. So here in this article, you'll go and read, you'll get the link in the description below. You'll get that we have already defined what active learning is. Another thing is that active learning implies that students are engaged in their own learning. So whenever you are going through a programming or a data science tutorials, you should also ensure that you are engaged in your own learning. Now, when we talk about active learning, on the other hand, active teaching strategies have students to do something other than taking notes or following directions. So other than just sitting there watching tutorials, other than just sitting there and taking notes, you should be involved in doing something. And in the context of data science and programming, this involvement in doing something is building projects, is coding along with the tutorial or with the book that you are reading. That students should participate in activities, that is to construct new knowledge and build new scientific skills. Active learning also engages students in the process of learning through activities and or discussion in class, as opposed to passively listening to an expert. So already we are seeing another bullet point here is that when you are going through coding tutorials, you should not just be a passive listener. You should not just be a passive listener whereby you just sit and listen to an expert. Now, when you are getting into active learning, which will make your learning way much easy, is that you should be engaged in the process of learning through activities and discussion in class. And if you're not in class, we'll see how you can do this discussion if maybe you are learning online and you are somewhere alone. Now, as opposed to being a passive listener. And now, this active learning emphasizes higher order of thinking and often involves group work. And as we have said, if you are not somewhere whereby you can get a group, how can you do this? But already we have seen active learning. Now, one of the ways of active learning, or one of the examples of active learning, is this that we get here. If you go to this article, KQED, Inform, Inspire, Involved, there's an article here which is titled, Don't Lecture Me, Rethinking How College Students Learn. And as we go through this rethinking how college students learn, you should also rethink how you learn, so that in the end, learning programming or data science should be very easy. to you. This by Mindshift in 2012. Now, it talks about Harvard Initiative on Learning and Teaching event which was held, and where professors gather to discuss innovative strategies for learning and teaching. So this is an innovative strategy for learning and teaching that was discussed, and that is what we want to instill in you, so that you'll be able to learn in an innovative way, so that in the end this learning process should be easy. And this article talks about Harvard professor Eric Mazur, who gave a talk on the benefits of practicing peer instruction in class, So we said in our outline, we said that we are going to look at active learning, and after looking at active learning and defining what active learning is, we'll go ahead and look at what peer instruction is. And already here we can see that Harvard professor Eric Mazur gave a talk on the benefits of practicing peer instruction, and we are going to look at peer instruction. Now, in this article, that most of the students in his lecture classes were not motivated to learn physics, and they didn't seem to be learning much. And are you that student who is not motivated to learn a STEM subject, or who is not motivated to learn programming or data science, and you don't seem to learn much even after spending so much money in tutorials, even after being held so much in the tutorial hell, and you don't seem to be learning much? What should you do? Now, here is that research that has been conducted over the past few decades shows it's impossible for students to take in and process all the information presented during a typical lecture. And when you are a passive listener, then all these tutorials will just be like the typical lectures. And researchers found that sitting through as a passive learner in a typical lecture has shown little result when it comes to understanding what has been taught. That's why it says here that it's impossible for students to take in and process all the information presented during a typical lecture, in as much as this is one of the primary ways that college students are being taught. Now, continuing in this, is that we are using here physics education as a platform to bounce into data science, looking at how, remember, physics is a STEM subject, and we are using that, how professors have found it well to teach STEM subjects, to apply that in programming and in coding, or in data science to be specific. Now, researchers, among them Reddish, who is now a leader, determined that the traditional lecture-based physics course, where students sit and passively absorb information, is not an effective way for students to learn. Now, you replace physics course with programming courses or data science courses. And now let us read again, that among whom Reddish is now a leader, determined that the traditional lecture-based programming course, where students sit and passively absorb information, is not an effective way for students to learn. A lot of students can repeat the laws of can repeat programming. We replace this physics with programming. Can repeat programming. Can repeat the laws, variable name laws and guidelines, as we learned last time. They can repeat that. They can repeat that data science algorithms time and again, and even solve complex problems. But many are doing it through rote memorization, and this rote memorization is what we want to take you away from. Now, most students who complete a programming course or a standard physics class as it reads never understand what these things that they have learned mean, or how to apply them to real-world situation. And we know very well that coding is so much applications heavy. Real world, you'll deal with real world data, real world problem, real world situation, real world decisions. And if you are a remote memorizer, then you'll find it in the end that it will be very hard to be able to apply this to real world situations. And you'll be caught up in the tutorial hell, whereby you'll think that the best way to learn is to buy another tutorial after tutorial after tutorial after tutorial after tutorial. So now, how do we move from there? Now, we want to have a class where everyone can be successful, because we need everyone to be successful. And that is what the Data Armory is up to, is that we want to have a situation whereby you are successful because you can be successful. And if you have been caught in the tutorial hell and seeing everyone else successful, building wild projects, solving wild problems in the society or in the real world, we also want you to be there, because you can be there. You can also be successful if you put in the work and you put in the hours and put the work and the hours in the right way. Now, that is Brian Lukoff who says that, an education researcher at Harvard who is studying ways to more effectively teach large classes. And it might not apply to large classes in a situation, but let us get the principles. Now, getting back to Mazur realized that even many of these Harvard students were getting through class by memorizing information, but not really understanding the fundamental concepts of physics. And here, we don't want you to be a student who just memorizes information, but who understands the fundamental concepts of programming or the fundamental concepts of data science. Now, we quick forward. So, for reasons he can't remember, Mazur told the students to discuss the question with each other in class. Now, he engaged them in active learning. And something happened in his class which he had never seen before. He says, the entire classroom erupted in chaos. They were dying to explain it to another and to talk about it. And that is why, as we learn data science, the best way or the easiest way for you to remember but not just memorize is for you to have that urge, that dying urge to explain it to another person or to talk about it or to teach it, and you'll get that through that you'll be able to remember and implement what you are learning. So Mazur says that just after a few minutes of talking to each other, most of the students seem to have a much better understanding of the concept he'd been trying to teach. So by you explaining, by you doing, by you practicing what you learn, you'll be able to have a better understanding of the concepts that you are being taught or that you are learning. So, and that is why Mazur now teaches his classes using peer instruction approach, and that peer instruction approach is what we are looking at. Now, when we talk about peer instruction approach, now let us look at what peer instruction approach is. Now we'll read from this article by Eric Mazur and Jessica Watkins, Just in Time Teaching and Peer Instruction. What do they define peer instruction to be? What do they define peer instruction to be? According to them, peer instruction is an interactive teaching technique. That promotes classroom interaction. Now, when we talk about classroom interaction, already we have seen that is a form of active learning, is a strategy of active learning that engages students to address difficult aspects of the material. So, whenever you are learning programming or data science, if you meet a difficult concept, if you meet a difficult aspect, then one of the ways that you can come out of that rabbit hole is through peer instruction, trying to explain it to someone else, trying to teach it, trying to talk to another person on this thing that you are learning. Now, by providing, and in their implementation of peer instruction, they did this by providing opportunities for students to discuss concepts in class. That is, peer instruction allows students to learn from each other. However, for this method to be most effective, students need to come to class with some basic understanding of the material. And if you are in a college setup, I think you have seen situations whereby teachers tell you to read in ahead or to read in advance so that when you come to class, you come prepared. That is a way of having you engaged so that when you come to class, at least you had a clue of what is going on. And that's why there's nothing wrong to read ahead before watching a tutorial. Like, for example, if you have a course outline, if you know that a tutorial next is going to tackle strings, the way we should be tackling strings, Python strings in our upcoming tutorials, there's nothing wrong with you going ahead, trying to understand what strings are, so that by the time that you come to the tutorial, at least you have a clue and it becomes easy to follow along. So how does peer instruction work? So here, the lecturer gives a brief lecture, then introduces the concept test and students vote, or he asks a question and students answer the question. After the students answer the question, if less than 30% of the students get it wrong, or if less than 30% of the students get the correct answer, that is, if 70% get it wrong, then the lecturer will revisit the concept. So he will revisit the concept. Again, if between 30 to 70% get the correct answer, now he will come back to peer instruction. He will lead them to peer instruction, whereby they talk to other students, they discuss it among themselves, they teach other students. Then again, the students will revote. Don't worry if you're not getting it. We'll explain it further and break it into details. Again, if more than 70% of the students get it correct, he will go ahead with the explanation and go to the next topic. Now, to break it further, what this whole process is, now here is how peer instruction works. So, increase student engagement and active participation during class using peer instruction. This is from skhs.queensu.ca. Again, you will have the links in the description below. So peer instruction involves this. Now, these are the steps that it involves, and these are the steps that we have just looked at in this pictorial. Now, it says instructor asks class question. After the instructor has asked class question, students answer individually, or students vote, as we have seen in the pictorial. Now, the instructor will go ahead and look at the student responses. After looking at the student responses, did a majority of class respond correctly? Did a majority of the class respond correctly? And when we talk about a majority of the class responding correctly, we are in at this level. Now, if yes, then great. Most of the class understands the concept. Continue with the lecture. If many have understood what they are learning, then continue the lecture. Now, we look at this from the student perspective. Now, if you have learned something and you have understood the concept, then proceed with the lecture. What about if you don't understand and it becomes difficult? That is now where active learning comes in. It doesn't mean that active learning cannot come in whereby you have not understood, whereby you have understood something. Active learning comes in whether you have understood or whether you are not understood, but more. It becomes even more important when things get tough, when things do not seem to make sense, when things get difficult, when you are trying to learn a science but you don't seem to make a headway. So if a concept has been given and you don't seem to understand it, now we focus much on this. It seems difficult. Now, peer instruction allows you to discuss and justify your answer to your neighbor. What about if you don't have a neighbor? We'll look at that. How do we go about it? Now, after the question has been answered, let's just take it back a bit. Did a majority of the class respond correctly? Yes, great. Most of the class understands the concept. Continue with the lecture. If no, then peer instruction comes in, allow students to discuss and justify their answer to their neighbors. Then answer editing, students answer again. Instructor looks at the student responses. Did the majority of the class respond correctly? Yes, great. Most of the class understands the concept. Explain the correct answer and continue the lecture. No, repeat the process starting at peer instruction and consider providing hints to help students with choosing the correct answer. So this infographic has been provided by SKH Culture of Learning Subcommittee. So it has just taken us back to all this process here about peer instruction. But remember, we are looking at it not from the teacher perspective, but we are looking at it from the student perspective, that if you don't understand something, engage in peer discussion. Engage in peer discussion. Try to explain this. And when we talk about trying to explain this, if you're not in a classroom setup, that is where rubber duck comes in. You have heard of rubber duck. You go and look for rubber duck debugging, whereby one way of debugging your code is by explaining it to a rubber duck, assuming that this rubber duck is a neighbor. You try to explain it to him, or you just talk it out yourself. Try to read aloud, or try to explain to yourself what you are writing or what you are coding. So peer instruction will mean that if you are in a class setup, and for example, if you were in this, if you are going through this tutorial on variable names and guidelines, there's this tutorial that we did last time. You will find the link up there. See the link up there at the right hand corner on top there. Now, is that when you are going through this, you have to code along. When we write the variable name student and give it a value Ken, you also have to do it. If you don't understand that, then explain it to yourself. If you don't understand this, explain it to someone else. Try to teach them as you move along. Or if you don't have someone to help you, then you can apply the rubber duck debugging principle, whereby you have a rubber duck and explain it to the rubber duck, or you explain to yourself by being engaged in the learning, not just being a passive listener. So at least by the end of this now, I believe you are able now to implement active learning strategies. And now these are just given you a headway to go and look for other active learning strategies, so that learning programming should be easy and quick, so that you don't get held up in the tutorial hell. So that has been our study. At least I believe that you can be able to define active learning. You know what peer instruction is, and you can now put this into practice and go and find out more. That has been our study today. You can leave your questions in the comment section below. Like, share, and subscribe so that we continue to see how to make it easy, or how we can continue to have more data science concepts as we learn along. You have a blessed day.